The last topic of the semester is linear regression and correlation. Section 10.2 and 10.3, we're going to do three big things, three main objectives for the section. We're going to determine whether a linear correlation exists between two variables, either yes or no, there appears to be a linear relationship. If a linear relationship does exist, then we're going to find the equation of the line that best fits the data. And then we're going to use that equation or something else, and we'll talk about the something else, so that if we're given one variable, we can predict the other. It's the same process as in algebra when you have two ordered pairs and you find the slope of the line containing the two ordered pairs, and then you find the equation of the line, and you can use that equation to predict other things. It's the same process. The only difference is in algebra, we only had two ordered pairs. We were only trying to find the line that fit those two ordered pairs. And in statistics, we may have 100 ordered pairs from our experiment. We're still answering the question, does there appear to be a linear relationship? If so, what's the equation of the line? And given some x, predict the y value for it. One of the things that was difficult yesterday, some folks just didn't know what I was talking about when I said slope of a line and equation of a line. That's why I added these two slides just to give you the two-slide review of the process in algebra. If we know that there's a linear relationship between two variables, x and y, we can find the slope of the line using the slope formula. And what that slope represents, and a lot of folks don't get this, yay, they get the number in the back of the book, they have the right answer for the slope, but they have no idea what it means. What slope tells you is how much y is increasing or decreasing for each unit change in x. Either as x goes up, y goes up, or as x goes down, or as x goes up, y goes down. One of those two scenarios. For example, if you give me two ordered pairs, 0, 6,000, and 10, 20,000, and you tell me that those two ordered pairs represent the value in dollars of some artwork X years after it was purchased, then this first ordered pair would be 0 years after it was purchased, or when it was purchased, the piece of artwork was worth $6,000. 10 years later, it's worth $20,000. Given those two ordered pairs, I can find the slope of the line using the slope formula, and that slope turns out to be 1,400. What that 1,400 means is each year, the value of the artwork is increasing $1,400 a year. And if you know that, then you can find the equation of the line. And here's something else that's different than algebra. In algebra, you needed this formula to find the slope, and you needed either slope-intercept form or point-slope form to find the equation of the line. We don't have time to go over all those formulas from algebra, but what we're going to do in statistics, the calculator is going to give us the equation of the line, so you don't have to worry about that. Once we have the slope, we could find the equation of the line, and here's where you don't have to worry about how we found the equation of the line. But once we find it, we can make a prediction like, well, what will this piece of artwork be worth in 15 years? Just put 15 in place of X and punch it on the calculator. How much will it be worth in 20 years? Just put 20 in place of X and punch it on the calculator. In statistics, though, experiments are going to give us more than 2 points. If we have 100 points, what's the probability that all 100 points are going to lie exactly on a perfectly straight line? Very unlikely, very unlikely. So we're not going to be able to find the equation of a line that fits all 100 points, but we'll find what's called the line of best fit, the line that fits the points as well as anything can fit the points. And then we will be able to use that equation or something else to answer questions like how much will the artwork be worth in 20 years, or what will the parking garage capacity of this garage be? that example didn't go anywhere exciting. But anyway, we'll use our equation to make predictions. All right, the basic concepts of correlation. A correlation is just some type of relationship between the x's and the y's. That relationship may be linear or it may be something else. Sometimes there is no apparent relationship between the variables, but the only thing we're going to have time to talk about is linear correlations, data that can be modeled pretty well by a straight line. And the first question on the quiz you just took was, what does R measure? R measures the strength of the linear relationship between two values. Last question on the quiz was, between what two integers does R always lie? What was that? -1 and +1. -1 would be a perfect correlation, a line that has a negative slope. +1 would be a perfect correlation for a line that had a positive slope. And then 0, there doesn't appear to be any correlation at all. The data points look like a shotgun blast. They're not forming any noticeable pattern. So R measures the strength of the linear relationship. It doesn't tell you anything about other relationships. You can see the relationship often by looking at a scatter plot. Wonder what just happened. When I re-uploaded that, I had all 4 of those on the same slide. I'm not sure how that happened. It's okay though. This first illustration shows a set of data with a pretty strong linear correlation. It looks like as your x gets bigger, your y's get consistently bigger. Certainly they don't fall exactly on a straight line, but I could guess where a line would be that kind of went through the middle of all of those points. And notice this R value, positive 0.851. 0.85 is pretty close to 1, and it's positive because the y's are increasing as the x's are increasing. The slope of the best fit line, I don't know what the best fit line would be, but I could tell its slope would be positive. This is an illustration of some data that fits more closely along a straight line than those points in A. There's less variation from that line. But this line also, I could tell, would have a negative slope, and the negative R value indicates that. The third illustration, that's the shotgun blast. There doesn't appear to be any identifiable correlation between the X's and Y values in this data. And then in the D part, there's a distinct pattern there. It's not a line, and I may or may not remember the word for what that pattern is in algebra. Does anybody remember what you call that shape in algebra in the D part? I see why you say that. Yes, in statistics, we'd say that's kind of bell-shaped. In algebra, though, starts with a P. Nobody remember? It's a parabola. And do you remember what kind of equation gives you a parabola? A linear equation gives you a line. What gives you a parabola? Starts with a Q. Quadratic equation. Now, you don't have to know that in here. I was just seeing who remembered, and that's cool. But here there definitely is a relationship between the X's and Y's, but it's definitely not a linear pattern. And R is closer to 0 than it is either -1 or +1. There's the formula for finding the correlation coefficient. If nothing else this semester has made you kiss your calculator, this one should, because we're going to find one button that calculates that correlation coefficient for us. In 1986, this is what I was doing in undergraduate at LSUS. Thankfully, I did have a calculator with a plus button on it. That's about all I had. Again, everything we talk about today is applicable only to linear correlations. There are correlations that aren't linear. We don't have time to cover them. Properties of the linear correlation coefficient are, make sure you understand what R measures. It measures the strength of a linear relationship. Make sure you understand that R is always going to be between -1 and +1. And the closer to either of those extremes, the stronger the linear relationship. The closer to 0 an R value is, the less of a linear relationship there is. If all values of either variable are converted to a different scale, the value of R doesn't change. Maybe I'm conducting some marketing experiment, and in the U.S., my money is measured in dollars, and in Europe, it's measured in euros. We would have different Y values in our ordered pairs because they're measured on different scales. It wouldn't affect your R value. The R value doesn't depend on your units. And the value of R is not affected by which variable you let be X and which variable you let be Y. If you reverse all your ordered pairs, you would still get the same correlation coefficient. R is very sensitive to outliers, so when we encounter those, we have to think about whether or not they're accurate or perhaps that was a fluke. Outliers can drastically affect your value of R. All right, first example. This is a chart that gives the cost of a slice of pizza and the cost of Subway fare in 6 years from 1960 to 2003. And we want to know if there seems to be a linear relationship between the cost of pizza and the cost of Subway fare. Now, what does your gut say? Should there really be any relationship between cost of a slice of pizza and cost of a Subway ticket? Not unless the pizza was being delivered on the Subway system, and then if Subway fare went up, pizza fare would go up also. I don't know if in any metropolis in the U.S. pizza's delivered via Subway, but my gut says no, there really wouldn't be a relationship between the cost of a slice of pizza and the cost of Subway fare. Hey, the other thing it could be, though, is inflation. If the inflation rate is the same for pizza and Subway fare, then they could both go up about the same amount over a period of time, but we still wouldn't be saying one was causing the other. They both depend on the inflation rate, but the cost of pizza itself does not affect the cost of Subway itself. We want to construct a scatter plot. I'm going to show you how to do that on the calculator, and just look at it and say, does there seem to be a linear relationship? And then we want to find that value of R. Let the calculator find it for us. All right. You enter your data in list 1 and list 2 the same way that we've always entered data. We've never had any other function that we had to have data in both lists, but here we do. So go ahead and put the cost of pizza in list 1 and the cost of Subway fare in list 2. When you get all 6 of those ordered pairs in, look up and let's all stay at the same place. Yes, sir. Okay. You missed the very beginning. We didn't get through this lecture in class yesterday because I ran around trying to help everybody individually with their calculator, and every time I did, the whole class would just burst into song. Not really, but they burst into something. So I'm not going to do that today. If you have any trouble with your calculator, hang around a minute after and I will help you, but I don't think I can fix individual issues with calculators in class and still get through the lecture. All right, so when you have those 6 ordered pairs, you need to set up your stat plot editor, once you get everything set just like it needs to be, you're not going to have to do this anymore unless you drop your calculator and it clears everything. To find that screen, press second and Y equals. Y equals is the very top leftmost button on your calculator. Very top row. And right above it, it says stat plot. So press second and stat plot. Now you want to make sure that your plot 1 is highlighted and turned on and all the others are turned off. So it's probably that way already. Probably you're not going to have to do anything. But if plot 1 is not turned on, then highlight it, go down to on and press enter and it'll turn stat plot or plot 1 on. Same thing if you need to turn plot 2 or plot 3 off, move the cursor over on the top line, for example, to plot 2, and then move on the second line the cursor over to off and press enter. Make sure you have plot 1 on and the others off. And then this is an illustration of the different kinds of graphs your calculator will do for you. We want this first one that looks like a scatter plot. So make sure you have that highlighted. And then you'd have to tell your calculator where you saved your X's and where you saved your Y's. I put my X's in list 1, my Y's in list 2. This bottom row doesn't really matter. That's just telling the calculator what kind of cursor you'd like to see, or no, what kind of mark you would like the points to be represented by. Would you just like dots or would you like pluses? It doesn't matter what you choose there. All right. Again, once you set up that screen, you shouldn't have to go back and redo that every problem. Go ahead and exit that. Just go to clear screen. And then to get that scatter plot, it's under the zoom menu. The zoom menu is about the third button on the very top row. 2 buttons over from Y equals, I think. And when you pull up that menu, you can either enter the number 9 or you can scroll down to see that 9 says zoom stat. And that's what we want. Just choose zoom stat, press enter, and that's what you should get. If you don't get that, then hang around 1 minute after class. I'll figure out what's going on with your calculator. The person who borrowed it last from the library may have been doing calculus on it and changed the settings somehow, but I'll figure out how to get your settings correct, and then you won't have to worry about it anymore. Does it look like there's a linear relationship between the cost of pizza and the cost of Subway fare? Those fit a straight line pretty well. Does that necessarily mean that the cost of pizza is affecting the cost of Subway fare? No. Very first day of class, we said correlation does not imply causation. Just because there appears to be a relationship between two things doesn't mean one of them is causing the other. And that's still true here. But yes, there appears to be a strong linear relationship. My gut says that when I do find R, what's it going to be close to based on this graph? +1, -1, or 0? It's going to be close to +1. I know it's not close to 0 because that graph looked like a shotgun blast. It's +1 because that line would have a positive slope. So to find that value of R, we need to do a linear regression t-test. It's in the same menu as t-test and one-prop z-test. You press stat, move your cursor over twice to tests, and scroll down to letter F. Letter F says linear regression. I think it says t-test. I think I left out a T right there. Does it say linear regression t-test? Okay. That is the screen that will find R for you. Once you've scrolled down to that and pressed enter, here are the things that you have to choose on that screen. Again, once you set this up, you shouldn't have to change it anymore. on this homework, but you need to tell the calculator where you saved your x's, where you saved your y's. You want that frequency to always be 1. For reasons I'm not going into right this minute, for the linear regression t-test, you always want to have the not equal to highlighted. I'll tell you why in just a minute. But make sure you always have the not equal to highlighted. Scroll down to calculate, press enter. There's my results screen. If you get an error, the number one thing that would cause an error is if you don't have the same number of X's in list 1 as you have Y's in list 2. That would be something to look for. But if you have an error and you've already checked and you have the same number of X's and Y's, you just need to hang around a minute after class or come see me in my office and I can help you get your calculator straightened out. Now, actually, this is just the first screen of information that the calculator gives me as results. This T is a test statistic. That P is a p-value. You don't have to worry about what DF is. We're going to come back to A and B in a few minutes, but what I'm really interested in, scroll all the way to the bottom of the list. There's my correlation coefficient R. And I got R as approximately 0.988. Would you say that that's a strong enough R value to confirm a linear relationship? That's pretty darn close to 1, but how close is close enough? Well, it depends on the consequences of being wrong. That gets to confidence levels and significance levels. If somebody's going to die if you're wrong, then you want to be sure you're right. If somebody's just going to lose an hour of sleep, you can allow a little more wiggle room in your level of confidence. But we've got to find out a way to test that R value based on a certain significance level and either say, yes, R is strong enough for me to say there is enough evidence to support a claim of a linear relationship, or there's not really enough evidence to suggest a claim of linear relationship.